Hi students, today I will discuss one more important chapter, that is simple harmonic motion. So simple harmonic, right? So before that we studied already different type of motion now. Like one bike is going, one car is going now. Therefore whole body will be transmitted from one point to another point. That we call it as like a translatory motion, right? So if an object is undergoing like a circular path, like our satellites will revolve around the earth, so electrons revolve around the nucleus, so that is called circular path. So like fan is rotating, our earth is rotating, like, so therefore we know that these all are called as like a rotational motion. Now rolling motion we already studied so many different type of motions. Now here we'll study one is periodic motion. Periodic means what? Which will be repeats itself after regular intervals of time, or after every certain amount of time now, right? So like our oscillation is there, like our a child swing is there. So the swing it will complete right after every certain amount of time, it will be repeating itself now. Like circular path is a periodic motion, rotational motion is a periodic motion, right? So here oscillator motion therefore is a periodic motion now. Therefore like a pendulum oscillation now, it is a periodic motion now. Therefore which is going to repeat itself after certain amount of time, we will call it as periodic motion now. Okay, so periodic, right? So right, so we'll see the periodic now, right? So periodic motion, periodic which is going to repeats itself after certain amount of time. So the time taken to repeat itself, no, so the time taken to complete one oscillation, one vibration, or one rotation, like that, so that time we will call it as like a time period. Clear? So the number of rotations, so it will be repeating, no, after certain amount of time. So like in 1 second, no, the number of rotations made, no, we will call it as like a frequency. So time period is nothing but a time taken to complete one oscillation or one vibration. So frequency, what is meant by frequency now? Frequency is nothing but a number of oscillations by given time taken now. So here for time period, one oscillation is there, one, the time taken to complete one oscillation is nothing but a time period. Frequency is nothing but a 1 by time period now, right? What is the unit now? This unit is nothing but a 1 by second now. So second inverse we will call it as like a hertz also. So the SI unit is nothing but a hertz, right? So here dimensional formula is nothing but a t power minus 1 will be your dimensional formula, right? So these are the frequency, right? So time period. Now angular velocity also we know it, no? Should know it. What is angular velocity? Angular velocity is nothing but a 2 pi by t, or that is nothing but a 2 pi into frequency. Clear? So this is given as like a radian per second now. This dimensional formula is also same, t power minus 1. Clear? Angular velocity is also very important concept now. Now these are the periodic motion now. Now oscillatory motion. What is meant by oscillator motion or vibratory motion now? So like a pendulum. Pendulum, what it will do now? It will be able to oscillate like this. Clear? So pendulum. So pendulum it will undergo like a oscillator motion. So we'll call it as like a to and fro motion now, right? Oscillatory. So which will undergo like a to and fro motion now, right? So which will undergo like a to and fro. What is to and fro motion now? See here, this is one mean position. If an object is going toward this side and again coming back to this one, no, so this side it is 2 and therefore it is going like this and coming back, no. So this will call it as like a to and fro motion. Like our simple pendulum is there, no. This is our simple pendulum, no. So it will go like this and come back here, no, and come back now. Therefore so this is said to be like a to and fro motion now. Clear? So even spring mass pendulum is there, no, a spring mass pendulum, no. So what happens now here? So this is a mass, no. So it will be able to go like this, again go like this, again go like this. So therefore here 2, so this is 2 and fro motion. Clear? 2 and fro motion. Now, so which will undergo like a to and fro motion is said to be like a oscillatory motion. So here this is said to be like one complete one oscillation. No? So this is said to be like a one oscillation. 1, 2 and fro. So therefore this will be about mean position. No? So mean position, and this it will be your extreme positions onto this one. So this is your mean position. So these are the extreme positions. So this is your the mean position. So these are the extreme positions now. What will be the distance traveled in one oscillation now? So mean position to extreme position. Here mean position to extreme position we will call it as like a amplitude. So what will be the distance traveled in one oscillation now? So from here to here, A and A and A. So distance traveled in one oscillation. So in one oscillation it is nothing but a 4A. The time taken to move from here to here, it is nothing but a T by 2. Fully 1, 2 and fro motion is said to be like a time period is T. So time taken to move from mean position to extreme position is nothing but a, so T by 4. Clear? So T by 4 here now, from here to here, T by 4, T by 4, T by 4, T by 4, like that. Clear? So these are about oscillatory motion. But what is our concept now? Our concept is not oscillatory or periodic, right? Our concept is nothing but a simple harmonic motion, right? So what is simple harmonic motion now? Simple harmonic motion. So this definition is very, very important anytime. So simple harmonic motion is there. These things you should get into your mind. So first, if it is want to undergo like a simple harmonic means what? First one, it should undergo compulsory, so to and fro motion. Compulsory it should undergo like a to and fro motion. Compulsory mean position, extreme position should be there. Second one, it's acceleration. Acceleration of the particle should be directly proportional to the displacement, but acceleration and displacement both should be in opposite in direction. Therefore, acceleration is directly proportional to the displacement, right? So if I remove the right, so but the direction now. So if you write it in vector way, so therefore direction of your acceleration and displacement should be always in opposite in direction now. So if I remove this proportionality, I have to place one constant minus omega square x. If any oscillator motion which will undergo this condition satisfaction, no? So that is said to be like a simple harmonic motion after this. Clear? So here acceleration, what is an acceleration now? So here we can write down in terms of displacement d square x by, so dt square, so it will be equal to minus omega square x, no? So you can take it as d square x by, so dt square plus omega square x, no? So equal to 0. This is your differential equation, so of our simple harmonic motion. Differential equation of the simple harmonic motion. So this is major condition onto this one, no? Simple harmonic motion. And one very important, acceleration and displacement both are in opposite direction. Means here one condition is very, very important, no? Most of the students will confuse how to take the direction now. Suppose this is our mean position now. Mean position, where mean position means what? Where total all the forces will be get balanced at this point, no? So like at it will be equilibrium position. At mean position, total forces are getting balanced. So when it is getting displaced here, no? So displaced. So here when it is goes to here, no? So therefore here there is a restoring force will be developed, so that it will come back onto this one. No? So it will be come back onto this, and then afterwards it will come back here, no? Come back, right? Like this. So how to calculate the directions here, no? We always remember that all the directions in our simple harmonic motion should be taken from the mean position only. So therefore amplitude means what? Distance between mean position to extreme position. From here to here only you should measure now. Therefore this is your x is equals to 0 position. So this side x is equals to plus a, this side x is equals to minus a position. Clear? Therefore you have to start from all the distances from the mean position itself. Here acceleration and displacement, no, we can take one simple experiment or a simple example, that is a simple pendulum, no, here. So this is your mean position. All the distances should be measured from the mean position only, right? So mean position only. So here, from here to here, it will be the displacement, no, but while coming to here, no, it is accelerating. So this side it will be an accelerating, this side it should be your displacement onto this. Therefore here acceleration and displacement are always in opposite in direction on this, right? So that is the meaning of this minus onto this, right? So here all the times whenever the simple harmonic motion is there, so immediately you should get into your mind this formula. And also omega, you know already formulas, that is nothing but a 2 pi by t. So that is nothing but a 2 pi into frequency. Clear? So these are the formulas which are required for simple harmonic motion. Now we will determine, okay, so can you we'll see one simple question here, no, see, we'll see, right? Here how the acceleration and acceleration is equals to omega square into x, how the graph it is there now, y is equals to minus mx, that is nothing but a, so it is a straight line passing through the center, so but it is a negative slope is there, right? So here, so y means acceleration, here it is a displacement. How the graph it will be there? So the graph for this one, no, it will be like this. Clear? So if you are taking this angle is about 45 degree, no, therefore we want to calculate the time period. How to calculate the time period now? So first of all, angle it is given. See, therefore here the slope, this is nothing but slope, is nothing but a omega square. Here how to calculate the slope here now? The slope is nothing but a tan theta. Slope is nothing but a tan theta. Therefore tan theta is nothing but a, so tan 45 is nothing but a 1. Slope is equals to 1. So therefore omega square, so it will be equal to 1. Omega is equals to 1. So omega value is nothing but a 2 pi by t is equals to 1. That implies t is equals to 2 pi seconds. Clear? In this way you need to calculate, therefore time period, if it is an acceleration and displacement graph is given now. Suppose sometimes no, the questions can be slightly modified. Here no, they will give the force here and they will give the mass. In that time, therefore again you have to calculate, you have to divide force by mass and you can get the acceleration, then you can able to do the problem, right? So this is one different model question. No? Now most important, whether what are the examples of simple harmonic motion, like simple pendulum, a swing, a spring mass pendulum. Here the molecules in an atom, therefore they are going to vibrate it, no? So and a cylinder, a wooden cylinder is floating inside on the water, right? A liquid in the U-shaped tube, like lot of things are there. So we'll see some different examples when you are discussing about the time period questions onto this. So now first of all, now we need to go for, so equation for our simple harmonic motion. This is most important concept, no? Equation, displacement equation. Now can you tell me circular motion is a simple harmonic motion or not? If you know the answer, please comment it, no? So pause the video and comment it. So but circular motion is a periodic motion, therefore there is no to and fro motion in that one, no? So circular motion is a periodic motion, so it is not a simple harmonic motion. But we will see one uniform circular motion to derive the equation for simple harmonic motion. How? So let us see. So we will take uniform circular motion. Uniform circular motion, right? What is uniform circular motion now? So there is one particle is there, it is going in a uniform circular path, right? Uniform circular motion means what? So time period is constant, omega is constant now, right? So here there is a one ball is there now. This is one ball, right? So it is undergoing like a circular path onto this, like this, with a constant time period. Time period is constant, but this path is not a simple harmonic. But try to see this one, no? Now what we will do now? We'll see. We'll focus the light here. We'll focus the light. When you focus the light here, there is a screen is there. This is a screen. Now where the ball it is there now? the ball is at this point, so it will create one shadow here, no, the shadow. Now the ball is moving here, no, so like this the ball is moving here, no, therefore the shadow it will go upward, right, and comes to here, so the shadow it will go upward, the shadow it will go upward and comes to here, no, then when the again the particle is coming here, no, again it will come down here, so comes to same the position, so again going down, therefore it will go down here, again it will go up, right. So this shadow is nothing but a simple harmonic motion. Clear? So particle which is going in a circular motion is not a simple harmonic, but the projection, therefore this shadow is nothing but a simple harmonic motion, or the projection on the y-axis, is simple harmonic. That means what is the projection in the y-axis now? We'll take the particle at this point now, so therefore when it comes to here, so it is making an angle theta, so therefore when the particle is coming here, so you try to observe my hand here, so when it is here it is like this, so when the particle is going, therefore it is goes to here, when the particle is coming here goes to here, so when the particle is coming goes to here, therefore it is maximum onto this, therefore here it is going like this. Now the particle is coming here, no, therefore going down, particle is going down, so coming here, going down, therefore coming to the again at mean position, again it is going down, so therefore I is going, therefore y projection is said to be like a simple harmonic. Even x projection also, if the particle is here, so therefore if it is going like this, x projection is also like a simple harmonic, correct. So y projection or x projection is a simple harmonic, right. When we have to take x projection, when you have to take y projection, we'll see. Now first of all our intention is equation for our simple harmonic motion, equation for SHM, right. How to do it now? Suppose this particle at time t is equals to 0, so when it comes to here in time t, therefore this it is rotating with a constant angular velocity, so omega is nothing but a theta by t, or theta is equals to omega t, therefore this theta is equals to omega t, so when it comes to here, so what will be the y projection here now? Y, this is your amplitude, right, this is theta, means this also theta, right, this is opposite side, this is hypotenuse, you can take it as this triangle here now, right, this is theta here now, this is y, this is a. What you can write it now? Opposite side by hypotenuse, sin theta is equals to y by a, or y is equals to a sin theta, theta value is nothing but a y is equals to a sin of omega t. This is your y projection. This is the equation for our simple harmonic motion now, right. We calculated is a y projection, y is equals to a sin of omega t. Similarly, if you calculate x projection here, no, so you have to calculate x is equals to a sin omega t. So sorry, a cos omega t, you will get it now. Therefore x is equals to a cos of omega t. How? Therefore again here cos theta, therefore cos theta is nothing but adjacent side by hypotenuse, you can get it now, right. So what are the equations of simple harmonic motion? No? These all are very very important for understanding, no, equation for SHM, no, right. So for SHM, let us see here, no, so y is equals to a sin of omega t, or y is equals to a cos of omega t, right. So basically when we have to use this equation, now, or this is x is equals to anything. So when we have to use y is equals to a sin omega t, and when we have to use x is equals to a cos omega t, very very important, no. So this equation we have to use it if a object starts from mean position, like if you are started measuring from, so the mean position now, therefore if you have started measuring from this mean position, we have started time t is equals to 0, so when it is at mean position, no, so this equation we have to use it. Suppose if you have started measuring from extreme position onto this one, no, so therefore you have to use this equation now. Clear? So x is equals to a cos omega t, you have to use if you are starting time t is equals to at extreme position, therefore a cos omega t. Suppose if you are starting the time at time t is equals to 0 at mean position, so you have to use x is equals to, y is equals to a sine of omega t. So both the equations it will be the same only. Sometimes if you are not starting with the time t is equals 0, suppose after certain time no, you are using no, so we will have some initial phase y is equals to a sine of omega t plus phi. Therefore, initially you are not starting time t is equals 0, you are starting some at certain point here no, like you are here you are not starting time t is equals 0. So say for making certain angle already 30 degree at time t is equals 0, you are starting from here. So therefore at that time, so initial angle will be there, that is nothing but a initial phase, right? Here these terms now you need to understand very clearly. So what are this one now? This is here, this y gives us the position of a particle, where it is there. So a is nothing but a amplitude, omega is nothing but angular velocity. So this phi is nothing but a initial phase. Initial phase means what? At what angle you are started. Initially I started here. So here I started. So when I initially started here, no, along this line theta is equals 0. That means initial phase was 0. So instead of starting from here, you have started from here, no. Initial phase already it will be there. So at that time you will get the initial phase of this one. So this is what? This is, we will call it as like a phase. Clear? Phase determines the position of a particle at what angle it is there onto this one. Clear? So these are the equations for our simple harmonic motion. So this is our equation, very important. So you understood, no? This one we have to use if it is started from mean position. If it is started from mean position. This you have to use when you are started from extreme position, no? When you are started from extreme position. Careful, no? So x is equals to a cos omega t. Now we will write down the equations for velocity, equations for acceleration, so and the graphs now, right? So first of all you got it, no, y is equals to a sine of omega t. Clear? So we want to write down, so velocity equation, velocity means you know it, no, again dy by dt. So do the differentiation now. A differentiation of sine is nothing but a cos. So cos omega t, omega, therefore a omega cos of omega t. So velocity is equals to a omega cos of omega t. Clear? So here in this one y, so a is nothing but a maximum displacement. So similarly for velocity, a omega will be the maximum velocity. Clear? So a omega will be the maximum velocity. Clear? So for y, a is a amplitude is a maximum displacement. For v, a omega is your maximum velocity. V max will be nothing but a omega. Clear? Now we will write down this equation in terms of displacement now. What you will write it now? See, this cos is there, no? Y is equals to sin theta is equals to y by a, or v is equals to a omega. We can write down cos nothing but 1 minus sin square omega t. Can I write it now? Sin square theta plus cos square theta is equals to 1. So cos theta is nothing but a root of 1 minus sin square theta. So here sin theta you can write it as y by a. So a omega root of 1 minus y square by a square. Y. So here sin theta is nothing but a y by a. I am writing now. So taken here now. So this a cancel here now. Therefore omega root of therefore a square minus y square. This is your velocity equation in terms of displacement. Clear? So this also very important equation, no? So velocity is equals to omega into a square minus y square. So here what will be the velocity maximum here now? So when it will be the maximum? When y is equals to 0. Y is equals to 0 means what? A mean position. Displacement is 0. Therefore mean position. Substitute, no? So v value will be maximum, that is nothing but a omega. You will get it. Clear? So y is equals to 0. Omega's root of a square is nothing but a. Omega into a will be your velocity will be maximum at mean position. Similarly, at y is equals to a, this is called extreme position. Extreme position. So a square minus a square, therefore velocity will be 0 at extreme position. Clear? Clear? If velocity is more, so kinetic energy will be more. Therefore, at mean position, so kinetic energy will be more. At extreme position, kinetic energy will be 0. Clear? So we will draw equation for this also. So now first of all let us go for acceleration now. What is an acceleration here now? Okay, so we got it as y is equals to a sine of omega t. So v is equals to a omega cos of omega t, or v is equals to omega into root of a square minus y square. Clear? So these are the equations. Now we want to calculate acceleration here now. Acceleration is nothing but what? dv by dt. So again do the differentiation now. A omega, differentiation of cos is nothing but a, so minus sign. Therefore here minus a omega, and again differentiation of this no square, so sine of omega t. Clear? So here a sine of omega t is nothing but y, so you can write down in terms of this one no minus, therefore omega square into y. This is our simple harmonic motion. Clear? Right? So here what will be the maximum acceleration here now? Here a is nothing but a maximum displacement, a omega is nothing but a maximum velocity, omega square into a is nothing but a maximum acceleration now. So what is your a max? Maximum acceleration is nothing but a omega square into a. So where it will be there now? Okay, so y it will be a, therefore so maximum acceleration will be at extreme position. Extreme position now. So at mean position, therefore y will be 0, acceleration will be 0 at mean position. At mean position velocity is maximum, at mean position displacement is 0, at mean position acceleration will be 0. At extreme position, so velocity will be 0, displacement will be maximum, acceleration is maximum. Clear? So these are the equations no, so which we got it by these derivations on this. Now we will go for the graphical representation for a sine, y and v and a, right? So what is a so displacement time graph? So here displacement y is equals to a sine of omega t. Most of the times the questions are coming from this. So here when omega sine theta graph sine 0, therefore t here no, therefore here it will be y. So when time t is equal to 0, 0, sine 0, 0. So therefore what will be the graph here now? It will be 0. So here you can write it now, y is equals to a sine of omega is nothing but a 2 pi by t into t. Clear? So time t is equals to 0, we got it now. So similarly, so time you can rewrite sine graph, you can draw it now. So you will get it as like this. Clear? So from here to here it is the time period is t. So from here to here it is t by 2. So here t by 4. Here it will be so 3t by 4. Clear? So from y complete this one no, it is said to be like one oscillation. So the time taken for this one is nothing but a complete time period on this. So maximum displacement, this is here plus a and this is here minus a. Clear? This is your displacement time graph no, right? In terms of angle also you can write down 0, therefore it will be 2 pi, is a pi by 2, 3 pi by 2. Clear? Now we will go for another one more, velocity. Here velocity and time graph. What is the velocity time graph now? Right? Velocity. What is the velocity here now? Velocity v is equals to, so that is nothing but a omega into cos of omega t. So therefore v is equals to a omega cos of, therefore 2 pi by t into t. So when time t is equal to 0, cos 0 is maximum. So how the graph it will be there now? Here it will be the maximum, therefore the graph it will be like this. Okay, this is 0, so therefore here it will be time period is t, therefore here it will be t by 2, so this is t by 4, this is 3t by 4. So maximum velocity, therefore this is a omega plus, so this it will be the minus a omega. Understood? So here acceleration time graph, no? So what is the acceleration time graph here now? So here we can write it as exactly, so this is your acceleration time graph. Acceleration and displacement exactly in the opposite direction onto this one, no? So exactly opposite graph here, no? So this it will be your, right? So this is your acceleration on this. Therefore here it will be the minus a omega square. So this it will be your plus a omega square. Clear? So this is your 0, this is t, this is t by 2, t by 2, this is t by 4, this is also 3t by 4. Clear? So these are the acceleration time graph, displacement time graph, velocity time graph. Now we'll go for velocity displacement graph. Velocity displacement, very very important, no? Velocity. What is the velocity formula? Velocity is nothing but omega into root of a square minus y square. So square it onto this, v square is equals to omega square, therefore a square minus y square. Therefore you can multiply it now, take it to this side, v square plus omega square y square is equals to omega square a square. Clear? So therefore here omega square a square we can divide it now, therefore v square by omega square a square plus therefore y square by a square, it will be equal to 1. So this is nothing but a elliptical way, right? So here, so this is your elliptical equation, no? Therefore how the graph it will be there? So the graph it will be velocity displacement. How the graph it will be there? Interesting, very interesting, no? This graph, it will be exactly looks like a ellipse. Now by using this graph itself, so we can determine, so most of the time then they will ask you velocity, angular time period, frequency, all this one. So here velocity is what, therefore it will be plus a omega, therefore it will be minus a omega, therefore here plus a, so therefore this is your minus a. So note down these values, no, so that this intercept which are there, no, by using this we can calculate the time period, so by using this graph itself. So this is very very important graph onto this one. Clear? Right. Now so we can have a lot of questions on this one, no? Some numerical questions, no? Now we'll go for another one more concept, no? That is force. What is the force formula? Force is equals to therefore ma, but acceleration graph is what is the now? Therefore minus therefore here omega square into m into omega square into a into sine of omega t. Clear? And one more thing, no? See here. Sometimes the questions can be asked, no? See here. A max by V max. Maximum acceleration by velocity maximum. So V max. What you will get it now? Maximum acceleration omega square into A. Therefore omega into A. What you will get it now? This will get cancelled out. So it will be omega. Omega, if you know it, no, that's all. You can calculate the time period. You can calculate the frequency, right? A max by V max, no. So therefore omega is nothing but you know it, no. Omega is what? 2 pi by t. So that is nothing but 2 pi into f. So if you know maximum acceleration, maximum velocity, also you can calculate the time period, right? So come back to this one, force. Force is equals to mass into acceleration. So m into omega square into a into sine omega t. This is your force formula. Force acting on the simple harmonic motion particle. Clear? Next one, potential energy. What is the potential energy formula? Potential energy formula is nothing but minus integral f into so dx. Clear? So what will be the force formula now? Therefore minus f into f is nothing but a is equals to minus omega square into y. So therefore we can write it as x or y, no? This is dy, right? So m into a, so minus of minus plus, therefore m omega square into y into dy. So what you can write now? Integral y dy, no, the y square by 2. So 1 by 2, therefore m omega square y square. This is your potential energy formula. Right? So when the potential energy is maximum now, when y is maximum. Where is the y is maximum here now? So y is, it will be A, that is nothing but a extreme position. Extreme position. What will be the potential energy formula here now? 1 by 2 m omega square A square. Right? So potential energy will be at a mean position now. So this is a mean position, therefore potential energy will be 0. Clear? Similarly, kinetic energy also we can write it now. What is the kinetic energy formula? Kinetic energy in terms of displacement, no? Therefore, half m into v square. So, half m, v value, omega into root of a square minus y square whole square. Therefore, 1 by 2 m omega square. So, a square minus y square. This is your kinetic energy equation now. Clear? So, when it will be the kinetic energy is maximum, no? So, at mean position. Mean position means what? Displacement is 0. So, kinetic energy is maximum. So, maximum, therefore, half m omega square a square. At extreme position, no? Extreme position, y it will be equal to a. So, kinetic energy will be 0. Clear? Kinetic energy will be 0 at extreme position, no? Kinetic energy will be maximum at mean position. Now, we will write down the graphs for this one. No? So, in terms of displacement, in terms of time. So, first let us write down what is the potential energy. Okay, this here we will write it now. This is here kinetic energy, potential energy. We can write down total energy. What is the total energy formula? Kinetic energy plus potential energy. So, kinetic energy is this one, no? Half m omega square. So, a square minus y square. Right? Potential energy half m omega square y square. Therefore, it will be plus y square. This will get cancelled out, no? Therefore, half m omega square a square. This is your total energy. So, which is always constant. Clear? So, this is your total energy is always constant. Total energy is directly proportional to amplitude square, and also total energy directly proportional to frequency square. Total energy is proportional to omega square. So, that is nothing but a total energy is directly proportional to omega is nothing but a 2 pi into f. So, total energy is directly proportional to the frequency square. More the amplitude, more the energy, right? So, more the frequency, more the energy. Now, we will draw the graphs. We will draw the graphs. So, first of all, let us write down potential energy. Potential energy half m omega square y square. Kinetic energy, what is the formula? Half m omega square. So, y is a square minus y square. Right? Therefore, a square minus y square. Clear? So, we will draw the graphs for this one. No? This is here. How the graph it will be there is like a parabolic. So, directly proportional to y square. So, this is y, this is your energy. How the graph it will be there? So, this is y is equals to 0. Potential energy will be 0. So, therefore, what about the kinetic energy graph now? Kinetic energy graph, it will be like this. What will be the total energy graph now? Total energy graph. So, it will be like this. This is your total energy graph now. Pink color line is nothing but a, this is total energy graph. So, blue color line is nothing but a potential energy graph. This is your potential energy. So, this brown color graph is nothing but a kinetic energy graph in terms of displacement. So, where it will be the kinetic energy and potential energy are both are equal, no? We can derive that equation, no? We will see. Before that, so we will go for in terms of time. So, here potential energy, what is the formula in terms of time, no? Half m omega square y is nothing but a square sin square omega t. So this is your potential energy in terms of time. What is the kinetic energy in terms of time? No, kinetic energy half m v is nothing but a omega cos omega t. That means omega square a square cos square omega t. Clear? So this is your potential energy and kinetic energy graph. Kinetic energy in terms of time. So we'll write down the graphs now for this. There. So sine graph is different, sine square graph is different. Be careful, no? Why? Sine graph is nothing but having the negative values, no? So sine square graph, negative values also will become like a positive values. Clear? Now here we'll write it, no? Therefore here potential energy is nothing but a sine square graph. Sine 0, 0. So therefore here this it will be the graph, no? How the graph it will be there now? This is here sine graph. This graph is what? It is in terms of time. Actually this is your energy in terms of time. What is this graph now? Energy in terms of displacement. Clear? So next here potential energy graph is what? Potential energy, this is your potential energy graph. So kinetic energy graph is nothing but a cos graph. Cos 0 is how much now? Maximum. So therefore here right. So this here yellow color line is nothing but a kinetic energy. So here white color line is nothing but a potential energy. This is your potential energy. So where about the total energy now? Again you add these two sin square theta plus cos square theta. So therefore this will become like a 1. So therefore this is your constant line is nothing but a total energy graph. Clear? So these are the energy versus time graphs now. These are the energy versus displacement graph now. Right? Clear? So here these are the formulas now which are involved for the basic simple harmonic motion equations. We will do some questions on this one. No? Let us see here. Suppose here we know it, just now we got it, no? So what is the maximum acceleration now? Maximum acceleration is nothing but a 60 centimeter per second square. Suppose this is given as maximum acceleration. So and maximum velocity V max it is given, no? Therefore 30 centimeters per second. So we want to calculate. So we want to calculate the time period and amplitude. Right? We want to calculate time period and amplitude. So just now, whenever there is a question is there, you need to think over it. What are the given formulas and what we require after this. Here acceleration and this one. What is the acceleration formula? A max by V max. We know it now. Just now we derived, no? That is omega square into A by omega into A. This will get cancelled. One get cancelled now. Therefore it is omega. Clear? So omega we will get it now. How much will get it now? Omega. So A max is nothing but a 60 divided by 30. So therefore this is nothing but a 2. So here 2 radians per second omega. But we don't want omega. Omega is nothing but a 2 pi by t. So is equals to 2. Therefore t is equals to 2 pi by 2. Therefore pi seconds. What will be the time period? We got it now. Time period is nothing but a pi seconds. Now what we want to calculate? A max, no? Therefore, sorry, A maximum. So we know V max. What is the V max formula? A omega. V max is how much now? 30 centimeter, no? So centimeters per second. A into this is nothing but a 2. So here A it will be equal to 15 centimeter. So time period we got it now. Therefore, so amplitude also we got it. Clear? Now we'll see. So where kinetic energy at what position now, right? At what position? So where kinetic energy and potential energy both are equal. We derived this one now here. So this is a point where kinetic energy and potential energy both are equal now. We want to calculate at what position kinetic energy is equal to the potential energy. What is the formula here now? Kinetic energy formula of m omega square a square minus y square is equals to half m omega square y square. These two are get cancelled out onto this one. No? Therefore, a square is equals to 2y square. So, a square is equals to 2y square. Y is equals to a, therefore y square, therefore a by 2. This is a by 2. Y is equals to plus or minus a by root 2. At this point, therefore kinetic energy and potential energy are equal. So, what are these points now? Therefore, here plus a by root 2. So, this is minus a by root 2. These are the positions where kinetic energy and potential energy both are equal now. So, one more question now. So, simple thing. So, here now, so suppose here one question is given now, y is equals to, therefore here it will be 10 into sine of, so 20 pi t plus therefore 37, right, like this is given now. So, we want to calculate what will be the, so maximum velocity, maximum acceleration, velocity equation, all this one, what are the things now. Therefore, first of all you have to compare this equation now, this all are in centimeters, time is in seconds. So, this is in centimeters, right. So, what you can write it now, y is equals to a sine of omega t plus phi. So, initial phase is nothing but 37 degrees, right. So, here amplitude, what is an amplitude now? Therefore, 10 centimeter. Here omega is nothing but 20 pi, but omega is nothing but what? Here 2 pi by t, so is equals to 20 pi. So, get cancel out, no? T is equals to 1 by 10 seconds. So, time period, clear? So, we want to calculate omega, Vmax. What is Vmax formula now? That is nothing but a omega. A is how much now? 10. So, therefore, here it will be 20 pi. So, therefore, 200 pi. So, centimeters per second. Similarly, A max also we can calculate it now. That is nothing but omega square into A. So, substitute it now. So, here you can write it as 20 pi whole square into 10. So, therefore, here it will be 400 into pi square into 10. So, pi square is also 10. So, pi square is 100. So, therefore, 400, therefore, 4 into 10 to the power of 4. 4 into 10 to the power of 4 centimeters per second square. So, this is your acceleration now. Similarly, velocity equation now, acceleration equation now. So, these are the things now you can calculate it now, right. So, next one more question now. Suppose here there is this is your displacement and time graph is given now, right. So, therefore, here now these all are the, therefore, here it will be 10 centimeter, right. So, this side it will be the minus 10 centimeter, no. So, this is it, right. So, this is here in seconds, no. So, therefore, here it will be 8 seconds, here it will be 4, right. So, like this, this is 0. Now, we want to calculate what is the time period now. So, time period for one complete oscillation, no, time period is how much now? Therefore, 8 seconds. We can calculate omega. Omega is nothing but 2 pi by t. So, 2 pi by, therefore, 8 pi by 4 radians per second. We can calculate. So, Vmax, no, what is Vmax? A omega, A is what? So, this is your 10 centimeter maximum displacement, no? 10 into 10 to the power of minus 2. So, omega is nothing but pi by 4. So, therefore, here 10, therefore, pi by 40 meters per second. This is your Vmax. Similarly, you can calculate A max. Also, displacement equation also you can write it now. What is this equation displacement now? So, this is nothing but as 10 sine of omega. Omega is how much now? Pi by 4. So, therefore, pi by 4 into t So time t is equal to 0. This is your displacement equation. Understood? No? Like this we can calculate some more questions. No? Suppose one more question. No? Suppose here. So here y1 is a displacement. So y1 is a displacement in time. Okay. So at a displacement we have velocity v1 at a displacement y2. So having the velocity of the particle is v2. We want to calculate the time period. So we know what is the velocity equation now. Omega into root of a square minus y square. So velocity, so v1 square, it will be equal to omega into a square minus y1 square. Clear? Now therefore v1 square is equals to omega into a square, sorry here omega square minus omega square y1 square. Clear? Similarly we can write down the equation for this situation. No? Right? Here v2 square is equals to omega square a square minus omega square y2 square. You can subtract these two. So what you can write it now here, v2 square minus v1 square. We are subtracting this minus therefore this minus of minus plus. This will get cancelled out onto this one. No? So therefore omega square y1 square minus y2 square. So omega square v2 square minus v1 square by y1 square minus y2 square. Therefore here omega, what is the omega here now? Root. Clear? Therefore time period, what will be the time period now? It will be 2 pi by t. So root of v2 square minus v1 square by y1 square minus y2 square. So you can calculate the time period of frequency or whatever may be that. No? If you got omega here, so you can calculate whatever the things can be asked. Clear? So like this we will do some more one fully numerical part onto this one, no? And the simple harmonic motion. Fully minimum 30-40 questions, different variety questions. No? We will take it, we will make it as like a problems video on the simple harmonic motion. In the next video we will discuss simple pendulum, right? So and all the applications related to the simple pendulum. No? So and next one, no? We will go for spring mass pendulum. No? So and different type of like cutting of the springs and all this one, no? We will discuss in the next video. Please thank you for watching my video. So please subscribe to my channel.